What if you could run a powerful AI model right now on your own machine with no API built, no data leaving your building, and no rate limits? It's not a toy model, a genuinely capable one. That's what local AI makes possible in 2026. And today's guest has been doing exactly this for real enterprise clients. Welcome to Data Science with Sam. I'm your host, Sam, and this is the episode where we cut through the hype and get into the hardware part of AI. And also, we talk about frameworks and the architecture that making running AI locally not just viable, but for certain use cases. My guest today is Trent Rossiter, founder and principal consultant at Logic Data Solutions, a boutique AI and data consultancy. Trent's built his practice around real production grade work. Denodo data virtualizations, Databricks, Snowflake, AWS, and Azure, and more recently, custom AI solutions, including fine-tuned models, AI agents, and computer vision systems. He's worked across industries where performance and data governance are non-negotiable, which makes him exactly the right person to talk about when and why you would run AI on your own hardware. Trent, welcome to the show.
Thank you very much, Sam. I appreciate the invitation to join you here. And yeah, I'm delighted to talk about this. This is a topic that I live and breathe every day. I cannot stop thinking about it and am super excited to be able to share some of these thoughts with you.
Thanks, Trent. So let's get straight to the big question that frames everything else. The cloud versus on-prem debate is heating up. What was the moment you realized running AI locally was not just viable, but actually preferable for certain use cases?
Yeah, for me, there wasn't like one specific moment that made me want to pursue more of the on-prem, more of the local models as opposed to the cloud providers. It really started as just sort of a general distrust with the cloud providers. It was not clear to me how my data was going to be used. I was uncomfortable with taking my data sets and actually moving it to the cloud. And, there's plenty of evidence that there's other people that are struggling with this. I saw a survey not long ago, 90% of its respondents were worried about the AI providers using their data without their consent. And that was sort of like the bubbling feeling inside of me is like, I don't know how this is going to be used. I'm not sure that it's smart for me to use these cloud providers in this way. And then you can consider some of the news headlines that are out there. It was this week, maybe even yesterday, actually. It was yesterday when Claude went down for hours. And that's not really a trust factor. That's just, an unfortunate circumstance from Claude. But it was just a few weeks ago that Claude had a major leak and some of their software got published to the internet completely by accident. And they had to go into damage control to do that. And I've mentioned two things about Claude and Anthropic. In my personal opinion, they may be the most trustworthy of the model providers. Like I really liked Dario Amodei. I think that he is a very sharp guy, and of all the players in this game, I trust him the most. He is, for any of your listeners that follow this sort of thing, know that was in the hot seat with the Department of Defense. He was the one that set some hard lines on how he wanted his technology to be used and how he specifically did not want it to be used. And they felt like very reasonable hard lines, like not mass surveillance on Americans, as an example. I think we can all agree we don't want this technology to be used for that. As soon as that happens, other AI players step in and say, we're willing to go there. So when you hear stories like that, it certainly does not bolster trust, and it's certainly not all of the providers that they're going to be using your data for purposes that you would agree with. So that's my personal opinion about it. There's also the corporate factor of it. Like you might work in an industry where using cloud providers is just generally frowned upon. Yeah, certainly all the cloud providers have created walled off areas and different security standards that try to address the data privacy concerns there. Some people, some organizations just still they don't want to take that step and they don't want to put their data in the cloud. But for those types of industries or those types of companies, local AI is really your only solution. Either you implement local AI or you miss the AI bus. And so that's the decision that they're faced with making.
Yeah, so it's, if I understand correctly, it's a combination of both compliance and also the cost factor, kind of like driven this kind of local AI
Mhm.
solution. Like a lot of small companies may not want to deal with the enterprise
Yeah.
scale API providers because they wanted to keep their data in-house. They don't want their intellectual property to go out there and get exposed. And also they
Mhm.
can use open source models and stuff, maybe train them with their data at lower cost. So
Yes. Yeah, and that's exactly where I hope this conversation goes. Like there's plenty of enterprise grade GPUs that you can get out there. Really, the stuff that I've been focusing on as far as smaller scale, personal scale, small business scale, as opposed to someone who's got hundreds of thousands or maybe even millions of dollars of budget to invest in purely hardware.
yeah. I think we definitely kind of like literally creating a segue to the next question because it's kind of like related to the hardware piece of it. So walk us through the hardware landscape for personal local AI. When
Or
what should someone realistically budget and what specs actually matter when you're choosing between option. And again, your
yeah.
opinion could be like totally your point of view because there are plenty of local AI options there, but would like to hear from you, especially my listeners want to hear from you about how you're setting up a local AI from the scratch, with a limited budget.
Yep. So I'll definitely tell you about how I've chosen to do it and why. But before I do that, let me just sort of describe a couple of the key aspects about the hardware and the different categories that we're talking about. By far, if you're going out there looking to build your own local system and you want to see like the narrow set of metrics, by far the most important metric that you could look at it is VRAM. VRAM is where your models are going to be stored. We're going to talk about some other more technical terms like KV cache and context and all that sort of stuff. All of that stuff gets loaded into the VRAM. So that is going to end up being the single biggest bottleneck for your capability at all. Now, VRAM itself is not all VRAM is created equally, I will say. So that's the second aspect that we're going to talk about is about memory throughput. That's how fast can your VRAM operate. Now, when people think about VRAM, they probably think first about gaming graphics cards, your NVIDIA RTX graphics cards. And there's a whole slew of them, the 30 series, 40 series, 50 series. Now there's even a 60 series. These are very high end, yet personal products, right? They're made for consumer grade. These are not enterprise grade products. And so they make them feasible for people running locally AI to use them. And I'll use feasible in air quotes here because they're still very expensive products. They consume a lot of power, they generate a lot of heat. If you've ever seen one of these things, they're massive. They've got multiple fans on them, and you have to really match them up with an appropriate power supply. And so that alone can be a little intimidating. The advantage of those types of systems is that they have very, very fast VRAM. The disadvantage is they're complex or a little bit hard to build. You would need a little bit of a nerd to go in and build this particular stack. And they're very limited on their VRAM. A graphics card to run a game might be 16, maybe even 24 gigabytes. These models are often far, far larger than that. So this series kind of category of local AI would be your very fast, relatively expensive for a personal use case, but limited in its capability without stacking it out. You're starting to get into a $10,000 system pretty easily. The second kind of category of local AI uses an integrated architecture where your CPU memory and your GPU memory are integrated together. And this is where I think that the majority of your audience is going to be interested in. This is coming in all sorts of form factors. Apple, I would say, in many regards, is kind of leading the charge. They have multiple platforms. I hear about people running things on Mac Minis all the time. The Mac lineup is extensive. They have, you go up from the Minis to the Pros to the Ultras and the Maxes, and you kind of need to do some studying just to understand the Mac lineup alone. The important thing to note there is that Mac is one of these integrated CPU GPU architectures. They're selling systems that have 64, 128, even up to, I saw one that was 512 gigabytes of unified memory. So compare that with your 16 gigabyte graphics card. This is way, way bigger, right? The the disadvantage is that depending on some of those detailed specs, that memory speed is going to be your limiting factor. And we're going to talk about frameworks too, which is going to be a factor in this, but I'm going to save that for a little bit and continue with the hardware. AMD is another brand that is really investing heavily in AI. I am seeing plenty of new architectures from Corsair AI and this other mini AI PCs with AMD architectures in them. Many of those are also running these integrated architectures where CPU and GPU memory is being unified. I ended up going with the NVIDIA stack. So NVIDIA released the GDX Spark. It boasts 128 gigabytes of unified memory. It runs a full CUDA architecture. So that was important to me. Of the stack, it is probably the slowest as far as actual memory throughput, that performance of the memory chip itself. However, I ended up going that route because NVIDIA is just leading the charge. While Apple is probably, I don't have specific numbers on this, but I would guess that Apple probably has the market share for personal AI. That's kind of a hard metric to even find. You don't know what people are actually using their Mac Minis for. AMD, like I said, making that push to try to capture that market. But as far as the AI market in general, NVIDIA has by far in the lead. And so for my personal use cases, like I'm doing things for enterprise clients, I need to have a local structure or a local architecture that allows me to test things on NVIDIA stacks, the whole stack all the way through. So for my particular use case, I ended up going with the GDX Spark because it was more compatible with what my clients are doing.
Yeah. And definitely, I definitely agree with you. NVIDIA GTX still front runner in the market, especially when it comes to the processing power.
Mm-hmm.
Uh, I remember my early days when I first got into the CUDA, and they are definitely the trailblazer in that space. I remember when Google, the studio at the Google Lab, it started coming up with that, making that possible for people like me who doesn't want to deal with the hardware, keeping on the software
Mm-hmm.
world. But I do feel like at some point of time there are gonna be more competitors coming, like AMD
Oh yeah.
already competitor, and I won't be surprised if Anthropic or Google are gonna start building their own infrastructure or processing power, and maybe something
Yeah.
that they would think of, okay, why do I doing a partnership with NVIDIA if I can build something on my own? And that's why we're seeing a massive push of building so many data centers around the world. Yeah, thanks for sharing the
Yeah.
insight. I would
And
love
Sam,
your tech stack, especially our listeners. And I'm probably going to ask you to give me some description, which I can share in the YouTube or the podcast vlog description for our listeners so they can try to replicate or maybe get some insights around how they can build their own local AI framework.
sure. And one other thing to note here is that, I failed to mention that in these unified architectures, they're fitting these things into form factors that are far more appealing. It's not everybody that's going to want this giant machine with LEDs and stuff in it like a gamer might, nor is everybody going to want a loud machine that's generating a lot of heat. These integrated architectures are generally very, very compact, very small. Their heat dissipation ends up being great. Their power consumption is lower. They're not loud. So that was an important thing for me too, is that I didn't want something that was a complete eyesore and that just felt completely out of place in my lab. So yeah, that's an important factor in this whole thing too. For people that are doing this personally, if you're going to put it in your office, You don't want a suitcase size machine. You want something that will fit on your desk.
So since we're talking about framework, I wanted to kind of like try to make a connection between the AI framework versus the local models. So there are
Sure.
several frameworks out there for running local models like Ollama out there, LM Studio, llama.cpp, or even Mistral or even DeepSeek, right? If anybody wants to kind of use DeepSeek for their local AI framework. So which ones have you had the most success with, and why do you think they have gained the traction they have? Like if you need some sort of like a performance or benchmark analysis across different
Yeah. Yeah. So yeah, this is a big topic. So and there's actually kind of a nesting of frameworks in here that we should go into. But you mentioned the frameworks like Ollama, Llama CPP, LM Studio, that sort of thing. When I first started doing local AI, I went with Ollama. And that is sort of like known to be like the easy way of getting in. Like its setup is very, very simple. You install a llama, you can just, if you want to do it from the command line, you can just say load this model. And if you want to do it from their graphical interface, you can select the model from a drop down box and say, I want to download it. Llama, Ollama is curating its own collection of models. So some of the things that we should talk about involve topics like quantization and things like that. Ollama makes it easy to not have to learn about all that. It knows what it can run, and you just get the easy button to say, I want to go try this one, and you can just run it. So very, very simple. Llama CPP is sort of tightly related to Ollama and is specifically designed to be able to run on CPU. Word of caution, anytime you're trying to run an AI model and run it on CPU, it's going to be very, very slow. I did this. I ran a relatively small model and saw it trickling along with Llama CPP and immediately was like, this is unusably slow. And this was on a relatively new machine that had 32 gigs of memory and multiple cores of CPU, but not a GPU that was going to be compatible with Ollama. So can you get it done? Absolutely, you can get it done. However, having access to a GPU that's compatible with your stack, which we're going to talk about, in my opinion, is going to be worth it. I also work with LM Studio and VLLM. LM Studio is probably the next level of complex. You will need to be mindful about things like quantization and exactly how you're serving it up, passing in additional parameters, none of which you have to worry about with Ollama. But it ends up it performs better for me. And in certain use cases, I use LM Studio now. For the vast majority of my work, I use VLLM, and it's a little bit more complex. With VLLM, you need to find compatible Docker containers. Luckily, as I mentioned before, I'm on the NVIDIA stack. NVIDIA creates these playbooks, and they create playbooks specific to certain hardware. And so for my DGX Spark, I always follow very closely to the playbook. I find that the minute I deviate from that playbook, I find incompatibility issues. The advantage, though, is that VLLM ends up running my models for, at least for inference, far faster. And so for anyone in the audience that doesn't know what I mean by inference, you can kind of think of AI running in two major stages. There's your training stage, which the majority of us will never see. ChatGPT or OpenAI does the training for us. Anthropic does the training for us. And then you just open up Claude or you open up ChatGPT and you start typing in questions. That is referred to as inference. So it's using the trained model. So for my use cases, when I'm using the trained model or using it for inference, I'm finding that the performance with VLLM is far better. There is another stack that's available, especially for NVIDIA, that's called NIM. That's more of the enterprise grade. I'm finding compatibility for my local AI setup to be pretty limited for NIM, but VLLM has been working well for me. And then it's a trade-off, like how easy do you want it to be versus how fast you want it to perform.
Perfect. Thank you, Trent. This is really a pretty comprehensive level of detail that you're sharing with my listeners here. And because as you mentioned about all these models, that brings me to my next question, because I wanted to pick your brain on the mixture of experts model. That's kind of another way
Yeah.
of testing, especially people nowadays. We are more prone to utilizing Claude Code or Codex, where, like you mentioned, the inference part already done, middle more
Mhm.
stuff. But if somebody wants to take care of the inference at the back end. Somebody wants to build that from the scratch, mixture of expert model, maybe sometime enable them to do that performance benchmark analysis and
Yeah.
maybe build something on top of what's already been pre-trained, right? So I wanted to ask you that, can you break that down for our listeners, like more in a like a simplified term that and explain why this mixture of or MOE models, like the acronym of
Mhm.
mixed experts, seem
Yeah.
to evolve their way when running locally compared to enterprise
Sure.
platform?
Yeah, mixture of experts, I'm a fan of. I'll say that outright. I think that that is going to be the next major wave of model architectures. Right before I go into that, I mentioned another level in the stack as far as, your tool stack and frameworks. It should be noted that NVIDIA uses CUDA. As I mentioned before, the things that are compatible with CUDA are not necessarily compatible with AMD or with Apple. AMD has their own underlying framework. So, like we talked about the frameworks for how to serve the model, but there's another level of framework that's how to interact with the hardware. And so AMD uses what's called the ROCm framework. Apple uses what's called the Metal framework. So I want to at least get that out there, because if you're looking to implement local AI and you're looking at the different hardware, this will start to matter. The mixture of experts models. These models, open source models that you would download and use for local AI, are basically like these giant networks of, they call them neural networks. The competing thought for mixture of experts is called a dense model. Most of the models that we started with were these dense models, meaning the entire model needed to be loaded into the VRAM in order for the model to be able to operate. Now, you can imagine that when you go and open, say, Claude and ask it a question about fertilizer for your lawn, and it gives you an answer, and then you ask it a question about history, and then you ask it a question about how to best set up your local AI model. Those are using very, very different bodies of data, right? And so a dense model would be that hyper smart person that knows everything about everything having to be loaded into your memory. The mixture of experts model says, oh, here's a question about fertilizing a lawn. Let me bring in my botanist expert and maybe my lawn care, something related to botany, to be able, maybe it's a chemistry person that's in there. And then when you go to ask a question about setting up your local AI network, your local AI system, it might be an IT expert, a networking expert, you know. And so the idea behind this, behind that mixture of experts, is it's only loading in the experts that are relevant for answering your question. The end all be all, the all knowing person that gets loaded in, I'm only loading in what I need. And so why does that make a difference? It makes a huge difference whenever you're doing inference and you're memory constrained. You know, I am running on a Mac Mini, let's say, and I've only got 64 gigabytes of unified memory. I can't load a 100 gigabyte model at all. But if it's a 100 gigabyte mixture of experts model, there might only be 30 experts that are active at a given time. So the amount of memory that you need to have in order to execute the model is far, far smaller. So, for example, I'm running Nemotron 3 as one of my mixture of experts model. I think that that one is a uh, 32, I think maybe a 30 billion parameter model, but there's only something like 20 or something like that that are active at a given time. So this makes running large smart models far more feasible on consumer hardware.
So let me ask you one thing. Now, since you mentioned the mixture of experts model, now there is another trend started ramping up called small language model. So
Mhm.
do you think at the end of the day, at some point of time, mixture of expert model is going to be eventually translating to small language model, where you have a smaller size model with that intellectual property or specialized in certain domain, And that's going to help with reducing the training cost, as well as it's going to speed up the query retrieval process for an organization. I believe that's where probably we're going to be heading in future, moving
Yeah.
large language model and kind of moving more into mixture of extrovert, which probably going to be a small language model, wrapper.
Yeah. So this train of thought kind of has a couple of different paths that you could go down. One, you mentioned, having a small language model that was very specialized in its language. You could take one of these models and continue to pre-train it so that it could speak a more specialized language. That's kind of one train of thought, is that, let's say I work for a legal company and I use very specific terms. It might not even be English. They might be old Latin terms, but they have a very specific meaning in legalese. You could then train your model to be able to speak that specific language. That's probably not exactly where you want it to go. But there's also like these smaller variations of models as well. So generally thinking about how do I take something that's very big and intelligent and be able to run it on something smaller. There might be a smaller variation, and the mixture of experts is one technique for being able to do that. What we're seeing now is that like Gemma 4, for example, released last week, I think. You're seeing a full family of models being released at the same time. They're all Gemma 4, and they have various parameters that are involved in it. Some that are designed to work on a cell phone,
Wow.
some that are designed to work on a machine more like what I'm running. Like I'm actively testing out Gemma 4 now, and there's ones that are big enough that I wouldn't try to run it on my machine because it's just too big. Is it, so they're releasing very, very small models to be able to use for different use cases, are then running mixture of experts model, and then they have their full capability dense model. In addition to that, like I think that this language that we're using of LLM or large language model is going to start to blend too. What we're seeing now is like when you generally think about a large language model, it is there to be able to speak language, thus its name. But the Gemma 4 is a multimodal model. All of them, the entire family is multimodal. And what that means is it's able to understand things that are not just language. For example, you can upload pictures and it can understand what's in that picture. I use this with Claude all the time, and it's telling me to do something, on, say some web portal or something like that. I'm able to take a screenshot and send it to Claude. Its ability to understand that picture and see the different links that are in that picture, that is the essence of multimodal. It understands that. There's going to be a wave, I believe, where people stop typing as much and they start speaking to their models. So
Correct.
sound, that is, one of the core aspects of being multimodal is to be able to interpret speech. So I think all these things are going to be happening, all at the same time. And I think they're all going to be advancing at a pretty breakneck pace.
Yeah, and I feel like that's where, like, when we start breaking down large language model for specialized use cases, that's where, all these mixture of models, those kind of use cases will coming up more. People, industry, the enterprise companies going to start
Mhm.
building models frequently just to something that can be their own or tailored to their use cases. And they can
Yeah.
take the noise out of other stuff because their model doesn't need to learn everything, right? I mean, I feel like
Yeah.
it's a human. If you draw that analogy, like a human subject matter expert, like the model is going to be more subject matter expert for their own domain.
Yeah. Yeah, so maybe you were talking about that. Like we talked a little bit about the continued pre-training so that it could speak your language. It's very feasible. If you're at a big organization, you could train your model to understand your own company acronyms, so that, in the event that you're using it for employees and they're typing in abbreviations and acronyms and all this sort of stuff, it understands what that means. And that customization will definitely be there. There's
Yeah,
also a technique called fine tuning that's very similar. The nuances are probably too detailed to go into here, but the idea behind it is that you can take a base model and be able to train it to do something more specific to you. For example, like some of the use cases that I've worked with is taking computer vision models and training it to pick out something more specific that wasn't in the existing training setup. you know
yeah,
this will be very popular in things like vision computer models for quality assurance. You've got products going down a line and you want to take a quick picture to make sure it got assembled correctly. Well, obviously, no model will be trained on what your widget looks like. It couldn't possibly know whether it was put together correctly. But you could fine tune it so that it could tell whether it was put together correctly. That's probably not a local AI use case, but it's certainly a use case within the enterprise.
Yeah, but you know, a certain enterprise, if they really want to kind of like don't want to keep their data out or
Yeah. Oh,
something
yeah.
built like locally, like proprietary image or videos or whatever,
Yeah.
they probably have to take that route of building something local. There are enterprise companies who have tons of money to invest in that
Yeah.
infrastructure. That would
Yeah.
be
I kind of misspoke. That there's certainly a local use case for that, not a personal use case for that.
now, talking about that, wanted to kind of like, get your thoughts on something which probably the data scientists or AI engineers or any data professionals listening to this episode would be interested in getting your feedback on that. For a developer, data professional or data scientist who want to start experimenting with local AI today, what's the most
Mhm.
common mistakes you see people make? And what would your ideal starter stack, like big stack, looks like?
Yeah. Okay. So common mistakes. Some of the common mistakes that I see are having expectations that are a little too high. This is a technology that, one, is emerging, and two, does require uh, a lot of compute and a lot of feeding, I would say. If anybody thinks that they're going to just say, you know what, I don't want to pay $20 for Claude anymore, I'm going to run my AI model locally, you are very likely to be disappointed. There's a reason that people pay for frontier models with, excellent hardware like what is running ChatGPT or Claude or something along those lines, would be to realize that this is resource intensive. So that would be one thing. You asked also about the starting stack of tools.
Yeah, tech stack.
Man, there is a wide range of these tools. For me, like the Ollama interface with just pure chat is of limited value to me. Like I want it to do more than what I can get out of just that interface of asking it questions. I want it to be able to do work for me. I want it to be able to call tools. Like I want to be able to create agents and that sort of thing and use AI to do actual work for me. Where would I start with that? I started with an open source tool called Langflow. It works really well. I've connected it to what's called MCP servers, model context protocol servers. This is sort of like the way to expose and use tools in a standardized way where you as a consumer don't need to worry too much about the plumbing of how to execute the tool. The framework itself is able to tell the agent what tools are available, what they're doing, and they can handle the inputs and outputs without you having to get caught up in the weeds. Another tool that I use for that type of thing is called Goose. It's sort of like a chat interface, but gives you the ability to attach to MCP tools. That one is really good. I also use anything LLM, and all of these are free tools, by the way. You can just download them and install them on your machine free of cost. Thing LLM is a really cool, and like it takes Goose to another level. It also has the ability to interact with MCP servers and give it tools and allow it to do work. But it has things like built-in vector stores that let you take your proprietary documents and load it into it. And then you can very easily ask your chatbot, basically your local model, to answer questions from a knowledge base that you provide to it. And this is going to be a huge use case, I think. Like we've all worked in organizations where there's a way that you have to go do something. Like how do I set up my phone to be able to access my email? And you've probably been in organizations where to do that, you either call the service desk or you're faced with searching through SharePoint to see if you can find the right document that tells you how to do it. Well, those documents can get loaded into a vector store. And then whenever you go interact with your chatbot, you can just say, hey, how do I connect my email with my phone, and it does the finding. It goes and finds the right document, and it doesn't just give you a link to the document. It says the first step is this. When you get that far, let me know, and then the second step is the second step, and it can kind of walk you through it based on your own proprietary knowledge base. So that's helpful even at a local level. Like even you can write notes for yourself about how you did something and feed that into anything LLM. It's a great tool for being able to do things like that. I take a lot of notes. The ability to find the notes about the topic that I want to go look up is very difficult. This is a tool to be able to ease some of that pain.
Yeah.
Oh,
Thanks,
and
Trent. Thanks
yeah,
for
we should talk about OpenClaw too real quick too.
yeah, sure.
That one is all the hype these days. We would be doing a disservice to the audience if we didn't talk a little bit about OpenClaw.
Yeah, just tell my listeners about how this local AI balance with OpenClaw. Is it OpenClaw?
Yeah.
Is it local AI?
Yeah, OpenClaw is definitely focused on local AI. It's kind of designed to be like this do anything type of agent where you can just run it and it can just do stuff for you. And I'm just getting my head wrapped around it. I got it configured the other day, and uh, it has its own Telegram account. I can interact with it. I gave it a name. It has its own email account. It can manage calendars. It can create sub agents. The dream of all this is that you can create things like a personal assistant that's all running locally. So I have it running with my local models. So nothing about what I send to OpenClaw ever goes outside of my lab unless I ask it to. To go search the internet for something, of course, it's going to go search the internet, to go and do that. A word of caution on OpenClaw, it already has a reputation of being a kind of a dangerous tool. I don't recommend that anybody just run out and go install this thing. And if you do, don't run it on your main machine. I have it running within a Docker container on an old machine that if the whole thing blew up, I wouldn't care about it. That's the level of skepticism that I put, on OpenClaw.
I think that's a really good suggestion. Running OpenClaw on a Docker container on a probably an isolated machine that doesn't connect
Yes.
to your networks and stuff. And honestly, I haven't tried OpenClaw for the same security reason.
Yeah.
And I try to keep up pace with all these AI things going on, to be honest with you. But OpenClaw is one of the only thing probably I haven't tried yet that's been around for
Yeah.
a couple of months. And that's mainly I probably have that skepticism of the security concern. I'm probably going to take your suggestion over there, and I'd ask our listeners to maybe follow Trent's suggestion on building something or putting an OpenClaw in a Docker container on an isolated machine.
Yeah, and there's some variations of it too. NVIDIA has their own flavor of OpenClaw. They call it NemoClaw, and it sort of is they're marketing it as the enterprise edition of OpenClaw. Like that's probably a little bit of an overstatement, but at
Yeah.
least what they're trying to do is go security first. Whereas when OpenClaw was first developed, it was sort of like anything goes open first. Now they're kind of toning it down a little bit. They're offering me right out of the gate a Docker option, and I have to create allow lists and things like that. Whereas NemoClaw is nothing is allowed. You individually tell it the things that it's allowed to do. And that makes it safer, of course. And in that regard, especially for an enterprise, it's safer, but it means far more configuration up front, setup costs, and frustrations perhaps, and that sort of thing.
And especially, going through the security and compliance review and getting your
Yeah.
security in on building something or putting something even with inside your company firewall. I mean, good luck with that.
Yeah. Yeah, if you're an enterprise, you're going to be under one set of restrictions. If you're trying to generate YouTube content, completely different set of
Yeah,
restrictions, right? And where I'm
definitely.
seeing the OpenClaw community being used, where I'm seeing OpenClaw used the most is primarily within communities like I'm trying to build YouTube content.
Exactly. It'd be more of like a social media marketing
Yeah,
and idea generation and, like creative styles where you don't kind of like deal with the PII, PHI, or kind of
correct.
free data. So I think it's going to be probably be isolated in those kind of areas. Well, Trent, genuinely one of the most practical conversation on AI I have had for last few episodes. So thank you for your time. So before I wrap up, I really wanted to know how our listeners will find you. Like, if you can share some details, how they can get in touch with you, or even like
Sure.
even on a personal project on local AI or anything as such.
Yep. You can find me on LinkedIn. My name is Benjamin Trent Rossiter. I think all three of those names are out there on LinkedIn. I am the founder of Logic Data Solutions. You can also find me at logicdatasolutions.com. I have a contact page there that, I'm not so popular that I can't just put my email address on there. So it's out there for you to contact me. And for anybody that's out there interested in doing local AI, I'd love to collaborate with you. If you're an enterprise looking for consulting services or anything of that type, I'm certainly open to that as well.
Thanks, Trent. And for my listeners, if you find this episode useful, share it with one person who is either drowning in cloud cost or wrestling with data governance, or even trying to find out how they can build their local AI for their enterprise grade software or even for their own personal projects. And that's exactly what is this episode for. I'm Sam. Subscribe to my channel if you like my episodes and videos. And I'm also available on Apple Podcast, Spotify, and Amazon Music. Recently, I got into iHeartRadio. So please listen there if you find my contents useful. Thank you, and I'll see you in the next one.